So, myth busting in Stinkbugs and Thrips. Just some of the things that are out there that we kind of rely, just as you said, like on your neighbor, the neighbor spraying, or peat or whatever, you know. It's you need to scout to find out what's going on your farm, and it differs between just, you know, from across the hill or whatever. Someone might be in a valley and it will be a totally different population timing to what's on your farm to the neighbor's farm. So just the hard facts about macadamias. I mean, I don't know if some of you are new to macadamias or not, but a mac tree, 15-year-old, they will produce something like 100,000 racemes, 10,000 racemes, and if there are 100 to 300 flowers on each of those racemes, you will get between 1 and 3 million flowers. All right, that's one tree. Okay, 90% of these drop. We know that we have those flowers that just looks like a curtain of flowers, and then we just see all the racemes on the floor, and there's a couple of flowers or nut sets still hanging. So of that remaining 10%, you're going to lose another 80% from the early nut drop, that November nut drop. So what you're actually working with is a very, very small percentage of the flowers. And a scientist, Urata, was one of the historical researchers in Hawaii, and he says that 0.3% of the initial flush would develop into mature nuts, and then some other people, Sake and Nago, they said 0.6. So between those two, that's what you're working with. And it's not only once you get it off the field that you have to worry about it. I mean, that little portion that you have left, you get the stink bugs, you get the moths, you get everything else going onto it. But it's also after you harvested, what you're doing with it in the stored bins and everything, you get another complex of moth coming in to those bins, and we pick up carob moth at that stage as well, and then tiny little beetles and weevils. So, you know, it's no wonder that it's a very valuable crop. So knowledge is key. Macadamias are a long-term investment, and when you do your research, please use credible resources. Don't just try and Google it. And if you're going to Google, use Google Scholar. Go to the nut growers associations. Go and have a look at what Australia is doing. They've been doing it for many years, even Hawaii. Go and have a look at what's been done, the research that's been done at universities as well. There's just, you must speak to the knowledgeable experts. So if someone says they have knowledge in chemistry, those are the people you need to speak to. You know, if someone says they're a plant pathologist, then you go and speak to them about their diseases. You know, so use those experts that you've got touch, but use them for their field. Okay. And we don't get do-overs with trees. You pick the trees from the seedlings, you go out to the nurseries, you pick the ones, you don't want the ones that are bent, you don't want, if they say they're yellow, you can just throw a little bit of fertilizer. Okay, you do that, but I want the green one, because you're paying for it, you know. So we need to protect what's left, and there are many species of pests that are becoming less susceptible. We can't use the word resistant, we will be sued. So you use this new term, less susceptible to chemicals, and the more and more active ingredients are being phased out, and it's time to return to biological control. And why I say return is that biological control was around way before chemicals. In 200 AD, the Chinese first used biological control agents. They used ants on citrus. So they would take an ant's nest, maybe it was one of these leaf ants, and put them on the trees to help with moths, for control for moths, and only the first insect pathogens, so that's your disease, your fungi, and that was only recognized in 1726, and that was a fungus on a noctuid moth. It's one of these, a noctuid is the tomato semilupa, the African bollworm, all of those. They what I call a cutworm when you start digging in the soil. And it was only post-World War II that they started developing synthetic organic pesticides. And with that, because when you spray them, they've got that quick knockdown system, we look at those now. Those are the ones to buy. So we have just been using those over and over again and sidelining the biological control solutions. So now the stink bugs. The two-spotted stink bug to me is the worst pest on macadamias. It has very, very long mouth parts. Its mouth part is able to penetrate the husk, the shell, and get into the kernel. And we all have this old chart. It was a subtrop or a ARC chart or SAMAC chart. I don't know who provided it. The life cycle of the two-spotted stink bug. So we've got egg, first nymph, and it goes all the way around to adult. And it states on that chart that there's 44 days required to complete the life cycle. Now, when I first started doing research projects for SAMAC, it must have been about 10, 12 years ago, I was looking at FCM and Magnat borer, trying to rear cultures of them. And I went on to do two-spotted stink bug as well. Prof. Ben Buerter from TUT, he was trying to identify the compounds that we could use, we could isolate and make a pheromone for the two-spotted stink bug, but it hasn't come about yet. So I was rearing all these. He couldn't rear the two-spot in Pretoria, didn't have the trees and the nuts and everything else, so I was rearing them in Nelspruit. And just looking at them, there is no way that those life cycles take 44 days. So I started having a look around and I found this degree days. I don't know if you guys have heard of degree days. It is the temperatures, the heat units in a day. So between the minimum temperature that the two-spot, it's species specific, so the two-spot minimum temperature it can survive at, or that it can continue with its growing, its reproduction, is 15 degrees, and the maximum is 35. So between that, those are counted out in heat units, all right? So every day they get a certain number of heat units. And so that's what's done in the laboratory, and the heat units are calculated using the lower developmental threshold, that's the temperature, and the upper developmental threshold. So you get the cumulative degree days, and that's put into a program and analyzed. It puts out the degree days and then the heat units, and you run that in combination with your scouting of your stink bugs. And you will see after you get to 338, that will be the rise, the first peak. Okay, so you have to get to a certain number of heat units, and for two-spotted stink bug it's 338. And so when you see it beginning to get there, you can average out the number of heat units, and you can say, okay, in 3 days' time it's going to get to that peak, so we need to start spraying now. Especially if you've got like a long delay, it takes you to do a spray round. So you can actually identify when the peak is coming, and you can start with timeous application. When you're looking at that 44 days as opposed to 21, you are half the way of a life cycle. And let's say a month has got 4 weeks. If you're a calendar sprayer, the first month you're going to be 1 week out. The second month you're going to be 2 weeks out, and so it carries on. So this whole thing about timeous application is very, very important. And if we don't have a look at saying, no, this doesn't seem right, let's just go and check it, then we have no clue. We just carry on with that for years and years and years, and of course the precision is not there, and we're going to get more damage at the end of the day. So when the weather conditions are ideal, the 2-spot is on average 21 days, and the applications are out of sync by 1 week on the first month, and so it continues. In Mpumalanga, the 2-spot only comes out in January. So that's 5 months until May, but they will carry on, but they'll start to decline after May because the heat units are not there, it's getting cooler. But that's 5 months. So that's an awful lot of sprays that you've been spraying, because we're getting towards when we're going to start harvesting, and you are spraying already in like almost every month. So yes, it will save you a little bit in your pocket, and you should be able to get more in your pocket because there's less damage. So as the colder weather comes in, it's going to take more degree days, and I've run it over 5 years worth of data, and it's the same every year. If you can manage to get it just before spray and put your application on, because we still need chemicals. But this also, because you have records and 5 years worth of data, you can go back and you can start with soil application of whatever before, if it's something like thrips, not stinkbug. Stinkbug doesn't have a soil developmental stage, but you can prepare like this. I've also got the days, the degree days for FCM, which I'm busy having a look at as well. So that would help for FCM, putting something in the soil to stop that life cycle coming through, the adults coming through.
When you hit your peak and you decide you're spraying, you then start counting again.
It's just cumulative. So then you go 338 and then you add 338 again, so it carries on to 672. Yeah, so it just carries on like that,
and we get to another 338.
Yeah. And it's always before the peak. So you can, when you start see it and you start seeing those degree units building up, then you know, and you can work out, okay, this week we got, let's say, 17 heat units, and you can almost forecast when it's going, and then just put it on earlier. Because if something is a contact or something, it will last.
And if you're scouting and you're not picking up anything, you still spray?
No. You go according to this. Yeah. But you have to be scouting properly. You can't just walk in a tree and have a look. That's very, very hard. You can't see anything. That's yeah. Anyway. So one of the other things I looked at was how many different species of stink bugs there are. You can imagine over 5 going on 6 years, how many insects you pick up. And we found that there were 24 different species of stink bug, and not all of them are damaging. We only found 3 that were reproducing on the tree, which means that macadamias are a host plant. Now, we also know that the grass stink bugs, they're not eating on the macadamias, and some of the coreoids, the leaf-footed bugs as well, they're on the weeds that are in between the rows. I measured the mouth parts to try and find out. We've got this thing about long mouth parts and short mouth parts and where they come in on the season, just to have a look and see how many had long mouth parts that were able to still penetrate or get to the kernel. And it was actually more than I'd initially thought. But most of these bugs that were identified, you don't find them in any particular, like a massive population. It's just over a very brief period of time. It might be for like 5 days or whatever, then they're onto something else. We must remember that if you leave and you have bush next door, give the pest insects as much other host plant choice as you can. This past year, we left the grass in between the rows, didn't cut it, and our thrips population, you have no idea how it dropped. It went from being a real problem to next to nothing. I mean, it's been weeks and weeks and weeks, and the thrips population has just been staying very stable, very low. Yeah. So,
what age are the trees?
Oh, all ages, right from about 32 years old or 28 years old, somewhere around there, to small plantings. Yeah, but we only do the scouting on the trees that are bearing. Yeah, yeah.
Sorry, what grasses did you have there?
We just left the weeds and the grasses to grow. We tried to get someone to supply with the white clover, pink clover, like a mix. You can get a mix of like 10 seeds. You can get lucernes and whatever, trying to put everything back into the soil. But when the manager put the clover down, then we had heavy rains and it all washed. So we had this big bunch of clover in one place. But yeah, even if you just let, a weed is just a plant we don't want to be there. It has a purpose. It's the same as the pests. It's just an insect that we don't want to eat our plants, So I would take out the nasty weeds, the nasty ones. If you see, a lot of weeds have also become, they lack susceptibility to the herbicides now. And I saw that because they would put something down and those weeds would come up, and they would put something down and it comes up. So just leave it. What I think, if you're trying to get the nasty weeds out, is after a rainy day when the soil is soft, get some people out there, put it in a bag before it seeds, and take it out. Remove it. So anyway, but so the stink bugs with the short mouth parts may damage the nuts when the nuts are small before they harden. But like I say, they kind of they don't stay around for long. There's this succession of stink bugs throughout the season. Sorry, yes?
What I want to ask is, at the end of just before you go to pick, there's, nuts have hardened off.
Yeah.
Can the stink bug still be damaged? Can it still draw into the nut?
Has it fallen down on the ground?
It's about 3 weeks before you pick.
If it's a 2-spot, yes.
Okay.
Yeah. Right until the very end, until you've removed everything. Yeah. Okay. Only 3 species use the macadamias. I've covered that already, and I do know that the coconut bug also used max as a host plant at the ARC when I was doing my my studies. The coconut bug, you'd find little nymphs in the max there as well. So with thrips, it's based on my thesis. I studied the biology and the phenology, the season of the macadamia. You always need to study the plant. And I reviewed which thrips were considered pests on other crops in South Africa, and to classify what thrips damage looks like on all the different developmental stages. So what it looked like on the flush, closed buds, flowers, and husks. And we also need to bear in mind that mites also cause damage. And you can see here, this little scratch here is showing you that broad mite have been on this cluster of nuts. So it damages the whole husk. That's not thrips. This here is thrips damage. There. Okay. It's almost like a scribbling on the husk. So I needed to relate the occurrence of the key thrips species onto macadamias, and I found out that the time when the populations were highest was when the flowers were open. So that, and I collected them, and there are a whole lot of thrips that eat pollen. They collect nectar. They do damage flowers as well. And then they were on the flush. The ones that are on the flush are the citrus thrips. And they flush is all the way throughout the year. And I don't know what it's like here in KwaZulu-Natal, but we have definite flushing throughout the year. The flushes that you need, the two big flushes, are spring and summer. The flush you need to protect is the summer flush. That is going to be next year's reserves and the following year as well. So that's the one that you must protect. So even if it's getting a little bit, hairy, if you can add something and try and control the thrip population whilst you've got another pest there as well, that's good. But yeah, the summer flush is the one that you really need to protect. So I also did a pilot study assessing a little yellow sticky card and trying to calculate the density of thrips. And this was useless because you'd hang that little trap out in the orchard, and in a week's time you would go and collect it. But wind also blows thrips along the orchard. So you don't know if the color attracted it, if it just was flying past, if the wind took it and stuck it on the glue. But the number on those traps do not come anywhere near what is actually in the orchards. And I think we would just freak if we had to understand or realize how many millions of thrips there are out in the orchards. I don't know if you've just walked through an orchard sometimes and you see those little almost like dust particles or whatever. Those are thrips. So when you've got a high infestation, that's what's going to happen to you. I mean, it's bizarre. We also wanted to find out whether the damage to the husk is purely cosmetic. People were very interested in that. And I did some research. I picked nuts that had thrips damage and those that were green. And I dehusked them, weighed everything up, put them in the ovens, dried them. No difference at all. No difference whether it's got some thrips damage on it or not. So the average life cycle of thrips, I've just added a whole lot of the agricultural species together, and this is an average life cycle. You can see that the egg, the first instar and the second instar, they're all, and the adult, are all above ground. Here, there are two developmental stages that are under the ground, and this is where their soft spot is. This is where you can target them. It's the propupa and the pupa, and these stages, they're not very mobile. So once they go into the ground, they more or less stay there. So if you can do something within that top layer of the ground where they're going to be developing, you can knock them out. And if you do something to them, I would suggest that you do a double tap, because then you'll knock the adults out and you'll knock the immatures out, and you'll have a longer breathing period before they come back again. So this is when anthesis, stop. What's going on? Around September is when the opening of the flower starts, and you can see that the abscised nut starts around September, and then it peaks in November. And the blue line depicts the total number of abscised nuts. The brown is abscised nuts with no thrips damage, and the green is with thrips damage. But it's very, 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 very little. That is, I could not identify which ones have fallen off the tree with thrips damage. You don't see like little bite marks or whatever. Once the tree has thrown off the nut, you can't tell how it's thrown off. You know, you'll pick it up and you have a look at that little stem and whatever, it's already gone black. You can't tell how it's abscised. What was the cause? So Thrips have built up resistance and cross resistance very quickly because they're also exposed with all the other sprays that go on. The choice of control measures are limited by MRLs, because if you're going to use a nasty, it's going to be picked up in the MRLs. And newer chemicals have lower persistence, but they are better for the environment, pollinators and natural enemies. But the timing of the spray needs to be precise. Oh no, it's doing this again. What's going on?
Maybe the battery's going flat. We'll just do it manually.
No. Can you help? I can't go and scroll through this. Now it's stuck.
Switch this thing off.
Something. Spray. Yeah, I was there back. No, one more.
This thing's battery is not like
Yeah, okay. Okay, so I identified species that are very similar. A lot of them, I think there were about 7 of them that were yellow. And to try and differentiate by the naked eye, you cannot see. So how the thrips on the right-hand side, they are citrus thrips. And you can see their antennae are a little bit different to those ones. That's Tenellus. Here we can see the wing pads here. And here the difference is in this moon, the shadow here. This one, the antennae, here on the side there are hairs. And here it's like a block, it's like a brick. So when we just do thrips, we just count thrips. We don't say it's specifically this or that. You will be able to see what thrips are, especially the citrus thrips, by where you are scouting. One of the questions I wanted to ask is, are some of the cultivars more susceptible to thrips damage? And the answer was yes. There are 3 different groups. The ones are A16. A16 is bad with... No, you see. No.
No, it's this thing. Sorry. I just tested it with the new battery.
Vilma, come here. Come here. I'm sorry.
One more.
So is that thing working now? No. Okay. All right. Okay, so there are 3 groups, as we were. A16 seems to have a whole lot of problems with regards to pests and being very susceptible to pest damage. Macadamias, and then the others. The others were Beaumont, Mac 2, A4s, 788s, and 816s. Is there a difference in unmanaged versus managed orchards? Now, I had some trial sites at the ARC and their orchards, which were unmanaged and managed orchards. Was there a difference? With regards to the abscised nuts, yes, there were a difference, but with regards to thrips damage to the husks, there wasn't a difference. How much does thrips damage contribute to abscission? We cannot quantify it because when I did pick the nuts up, dehusk, dry and everything else, the kernels that came out were mainly stinkbug damage. Abscised nuts with thrips damage to the husk in the first season of my studies, it was 22%, and in the second season, 15%. Does thrips damage affect the kernel maturity? No. So Madumbi, they strive to develop quality biological solutions, enhancing the soil and the plant health, producing pest control products which have minimal impact on the ecosystem. And this is the way that we're going to have to look because of all this loss of susceptibility or lack of susceptibility with the chemicals. Chemical companies now are looking towards biological solutions. And Madumbia has been around for a long time, and we have tried and tested products. So we need to move in that direction. We're not going to get rid of the sprays, but we can lessen them. And we have a new catchphrase now, the researchers, land stewardship is leaving land for our future generations. And do we really want to put all this chemical? These things are nasty. So with the development of the lack of susceptibility, numerous chemical families have become no-goes anymore, and we need to look at that holistic IPM approach. Healthy soils, nutrients, microorganisms, robust seedlings all contribute to vigorous plants, which are more resilient. They're going to be healthier, stronger. They can face the pathogens and the disease. So we need to get back to basics and only use chemical control when absolutely necessary. So before you spray for pests, remember, knock-on effects of synthetic chemicals to natural enemies and pollinators is too high a price to pay. So thank you for your attention and support. If there are any questions. When is tea?
Can thrips pollinate?
Yes.
Next.
Yes. You know, they're going, the ones that are feeding on pollen. Have you seen thrips under a microscope or just, I don't know. They are so covered in hair. I mean, they're almost as bad as a honeybee. They have hair all over them. And their wings are fringed with hair and going in and moving from flower to flower. So they are. We have no idea how much they pollinate. It's with anything that goes onto a Mac flower. It will get those little pollen granules on them and then transfer them. So it's really to, thank you for that question. Yeah.
Besides the cell phone scouting, how else can you?
Okay, what we did, because the traps don't seem to work, we get a piece of black matte paper and then on a clipboard, and then my scouts would go out and we would shake over this paper 5 different developmental stages. So if it was a flower, new flush, whatever, pin matchstick head, whatever, and we would count those thrips there, and then we would put it into a if they fly away, count them as well, but squash them so that more don't fly away, and then just get those counts, and I would average it out, and it all came to around about, it was just 50, and we just stayed constant at 50, throughout. You'll see when it starts to increase, and maybe another product that you've put on will help control the thrips numbers, but yeah, we would do that, and we do it once a week.
Do you reckon only that one summer flush is the...
That is very, very important. Look, the spring flush is important as well, but it's your summer flush that you need to protect. The little growth, it would be good, and we also have to remember that you've got small trees, which we didn't spray, and then all of a sudden they were a reservoir for the populations going into the big orchards, So every now and then you've just got to scout, you've just got to constantly have a look, but try with the grasses and the other plants in between and just see how that affects your thrips numbers. Yes?
Yeah, I was fortunate to have the opportunity of visiting a grower near Barberton. I think they harvest about 700 tons, but they don't spray. What they do is, I don't say they don't spray, they do spray, but they lay white sheets under certain trees.
Yeah.
And then they go in at 3 o'clock in the morning and spray that tree, and they count whatever's there, but
yeah.
They don't spray until it leaves the tree.
Yes.
That's all they do.
Yes.
So, being such a big farm, and it's incredible how
yeah.
it is not that.
Yeah, that's scouting. That's what we do with scouting. So what we used to do is we used to lay sheets under 5 trees. And we used to do 6 of those on one farm and 6 on another farm. And very early in the morning, your tractor drivers go out and they spray something. And you need to go 1 hour afterwards and pick up whatever is on the sheets. Otherwise the ants, the birds, the rats, or whatever, frogs will take it. Then you don't have an idea what was there. And through that, that's what we base our sprays on, whether we're going to spray. And even the nymphs, you know, they will fall down. And then you can see, okay, the nymphs are starting, so the eggs have hatched. So you can see, okay, this is where it all begins. So it is, that is crucial. That is how you scout properly. Yeah.
I have 2 questions.
Yes.
The first is the degree days. When you spoke about the degree days in stinkbug, is
Yeah.
the major contributing factor to the life cycle of stinkbug temperature, or are there other environmental factors?
There will be. It will be humidity, it will be whatever, but it's mainly, I'd say, the temperature that you're counting those heat units. So sometimes it would be like maybe 1 day later that the peak would hit. So there has to be something. All those temperatures are not exactly right. The 15 and the 35, maybe it needs to be tweaked a little bit. Maybe it's 15.5 or something. But it's as close as anything. And I would plot those on a... Unfortunately, the people I worked for, they said that I mustn't take any of my research. But I have asked them nicely, so hopefully I get some in the future. But you can see just when that cycle is around. I put a little star there, and you know, if we'd sprayed anything, and you can just see how the numbers drop, you know, and it's just magic because you save a whole lot on other sprays, and you can be using that money to do something else, you know. So I mean, it's just a win-win. And it's just a different way of looking at things, a new way of looking at things. Sorry, your other question?
My second question is about the thrips, and maybe it's an ignorant question because I'm not a grower. You said it doesn't do, if the damage is mostly cosmetic. So why are we spraying for them? Do we need to be spraying for them? This is the question I'm asking.
Yeah, we need to be spraying for the flush. For the flush. You know, people, when they say they've got so many thrips on their flowers and whatever, I would say leave the thrips on the flowers. They're doing a whole lot of pollinating for us that we don't even know about. It's the new flush. It's that factory for the next year. It's the photosynthesis. So those are the ones that I would do. Yeah.
Colleen, on that, maybe just comment on the work that you did with the yellow versus, because you didn't mention that, and that's fascinating.
Okay. We've got chlorosis. I don't know if you have it down here. We've got very yellow trees, and no one's certain what has caused it, if it's an iron deficiency or if it's this. Some people say, oh, I've got the thing to spray on it, and they'll come and they'll spray a foliar application or whatever, and it's green for 3 weeks and then it goes yellow again. We've had it where it starts to die back on small branches. You can cut it off and it will carry on. So we don't know what it is, if it was that horrible drought that we went through. But I wanted to see what the difference is in the nuts from a yellow tree, from these yellow trees, or from the normal green trees. So I picked nuts, did the whole process, measured them, all right, dehusked them, measured that, you know, went in, dried it, measured the shells and everything. The difference between the green and the yellow nuts, 50%. So you are still putting as much chemical on, fertilizers, irrigation, all of those things, and you are doing it for half the return. So we need to sort out those yellow trees, whatever it is. You know, if it's a disease or whatever, you need to make a decision on those. Whether you actually take them out, or whether you replace them, or whether you try and nurse them, or if you use some soil health products, you need to just get them back into a healthy mode, because you're losing a lot. And it's, you know, it's like, oh yeah, I've got a couple of yellow trees, but you actually, it's, yeah, big money, I think.
So you said something about controlling the thrips in the ground, what products were you talking about?
We have a range of products, and you have a pamphlet there to. You must read your book. I can't.
It's easier to ask you.
Can I maybe just help?
Yes.
So we've been playing around with EcoBB as a soil drench. There are quite a lot of entomopathic fungi available that they are doing soil drenches with and getting some really interesting results. So that's something you guys can play with and see if it works for you, but it depends on the soil type and where you put it down. So it's a very woolly situation still, not registered at all. No one is registered at the moment. Getting good results on grapes, good results on citrus.
Colleen, natural predator, thrips.
Other thrips. And yeah, there are many predatory thrips, and you will get the lacewing larvae. They will eat thrips and mealybug and whatever, and you also get like owl flies as well. They're tiny parasitoid wasps. There's all sorts of things, but they're soft-bodied insects. So there will be there's ladybirds. There's a whole lot of natural enemies there. Yeah.
Colleen, is there a host plant for thrips?
There's so many host plants, and there's so many hundreds of thrip species, probably thousands actually of thrip species. I mean, it's incredible. So it's just playing around, and at different times of the season they will move on to different things. And it's the same as the FCM. If we have a look at the whole cycle of our cropping systems and whatever, we must have a look and see if anyone grows oranges. When the FCM are on there, after that they'll move to the macadamias. After that they'll move to what other crops you've got. You've got to like have a look, and if we can control all of those stages to an acceptable level, you're not going to have a squeaky clean orchard. You know, you've got to have a certain amount that you write off to insect damage. It's everything feeds into everything else. It's a natural balance. So yeah.